Hey, welcome back to Mr. Mig's Classroom. I'm Mr. Mig, and I'm going to continue talking about the weather section of the FAA Part 107 exam. Let's get started with the FAA Part 107 exam weather section. If you're new to my videos, I ask that you give me a thumbs up and subscribe. This is the Part 2 to weather, so if you haven't watched Part 2 yet, go ahead and watch Part 1 first. A lot of my Part 1s and 2s, like my question review, it doesn't really matter. You could watch the part 3 first and then part 2 and then part 1. It doesn't matter. This one, I think it'd be better if you go back and watch part 1 first and then watch part 2. Without further ado, I'm going to go ahead and share my screen here. And I finally fixed it so it says Mr. Mig here, which is what I go by. My last name's a difficult name for my students to pronounce, so I let them call me Mr. Mig. It's easier. I love my last name. I'm proud of it, so you don't need to write in the comment section to be proud of the name. You can if you want to, but I'm very proud of my name. But it is easier for them, and I think it's a little catchier too. Let's see. Let's do visibility in clouds. I think that's where we left off. All right. So visibility in clouds. This is. I'm going to do another video on the life cycle of a thunderstorm, so I'll kind of touch on that in here too. But anyway, we talked about this last time. The FAA requires that you are 2,000 feet horizontally away from a cloud when you're flying a UAS, and that you're 500 feet vertically below a cloud. And so some people are like, well, what's the difference here? If you're a flatlander like me, I live in a coastal area, it seems like it's kind of odd, like that there's that difference, but it's really for people in mountainous areas. So people in mountainous areas are like, you could be up here on a mountain, right? Say you're up here on a mountain, and then like there's a cloud over here and it's coming in. You want to be 2,000 feet away from it because you could be on level with the clouds if you're up on a mountain, right? And there could be an airplane in the cloud and you don't see it until it's too late and you could run into it. That's not good. So that's why they want you 2,000 feet horizontally from a cloud. This does not mean if you're standing on the ground and there's clouds, say 1,000 feet above you, straight above you, that you can't fly. No, that's fine. If they're more than 500 feet above you, you can fly. It doesn't mean that they have to be both at the same time, 500 feet above and 2,000 feet horizontally away. No, that's not what that's saying. It's just saying like if they're at your level, right, then they got to be 2,000 feet away from you horizontally. All right, that's what they're saying, right? So if they're above you, they do have to be 500 feet above you or more, otherwise you can't fly. But don't think if there's like a cloud that's 20,000 feet, like a stratus cloud that's 20,000 feet above you and is straight above you, don't think, oh, I can't fly because it's not 2,000 feet horizontally away. It's like it's more than 500 feet above you, so you're okay. Here's a nice little tip. They might test on this, but it's just a nice little thing for a UA pilot to know. The remote pilot in command can determine local visibility by verifying a known point at least 3 statute miles away in visibility. Similarly, an object with a known height can be used to observe how high a cloud is. So if you know a tower is 1,000 feet tall and the clouds are above it, you're good. Or say a building's 500 feet high or even 400 feet high and the clouds look to be more than 100 feet above it, then you're probably good. Okay, the FAA defines cloud types into 3 general categories. We've got low clouds, middle clouds, and high clouds. Low clouds are 6,500 feet and below. Middle clouds are from 6,500 to 23,000 feet. And then your high clouds are way up there in the atmosphere. Places we should never be flying our UA. Really, we should only be flying in the low cloud area. Even though you're only going to fly in the low cloud area, they're going to test you on the exam about some of the middle and high clouds. So you got to know these things, even though we're probably not going to be affected by them as UA pilots. Okay, so let's see. So here's our different types of clouds. Right here, this is a cumulonimbus cloud. And go ahead and think to yourself or tell me if you want to, even though I can't hear you, what this is, all right? And if you want to pause the video and think about it, go ahead. This is a thunderstorm. That's what a cumulonimbus cloud is. Here's a cumulus cloud. This could be the start of a thunderstorm. So I'll talk about it in a different video. We get 3 stages of a thunderstorm. The cumulus stage, which would be this guy here, nice puffy cloud, kind of big, but not nearly as big as this huge guy, which would be the mature stage. That's where like things are happening, right? There's no rain happening in the cumulus stage, but this stage there is. And then you got the dissipating stage. So what we really want to know as UA pilots, we need to be aware of the cumulonimbus clouds because they're thunderstorms, and you don't want to be out in a thunderstorm. The cumulus cloud you should be aware of because that could be the start of a thunderstorm. And then obviously this nimbostratus cloud. That's going to be nice steady rain. We can't fly unless we have 3 miles of visibility, but as a manned pilot, maybe this isn't so bad, right? You could actually have pretty steady air or stable air in a nimbostratus cloud. But for us, we need to have 3 statute miles of visibility as UA pilots, so you don't want to be flying that. You'll want to know these clouds as well. They might test you on these. I didn't see a whole lot of questions on these upper clouds, just to be honest, but fair warning, they could be in there. These, you're going to get tested on. Anything down here, be prepared to know about these. Like literally the cloud type and name. Okay, so, and what you might want to do, maybe you want to make a flashcard and know these. Just be aware of them. The stratus clouds are low, thin, flat clouds characterized as stable air, and that's kind of what you'll want to know about them. Like what cloud is characterized as being with stable air? The stratus clouds. Cumulus clouds, white fluffy clouds, characteristic of unstable air because they have vertical currents. What's happening during the cumulus stage of a thunderstorm is you get these updrafts. And so that's bad because that's going to cause a lot of turbulence, right? So the cumulus clouds are things we need to be aware of and we need to be mindful of. You know, so know that. And that could be a question is cumulus clouds could be characterized as having what of the following? And it could say something like rain, stable air, unstable air. And it doesn't rain with cumulus yet, but it's going to have that unstable air. Nimbostratus clouds, a rain cloud with steady precipitation. Remember, the steady precipitation, as we talked about in the last video, had stable air. It was that showery precipitation that had the unstable air. Cumulostratus clouds, a rain cloud with showery precipitation. So nimbostratus would have steady, stable air. Cumulonimbus that's your thunderstorm, is going to have showery precipitation and unstable air. There's some pictures. I won't go into these as much. Just know your middle clouds, your altostratus clouds, and your altocumulus clouds. High clouds. All right. The only one you really want to be aware of here is your towering cumulonimbus cloud with an extensive vertical development, right? This one here, that's the top part of your thunderstorm. Thunderstorm clouds, I mean, these things are huge. Like let me go back real quick. It's like, just to kind of give you an idea, like this is like, if you can see it over here, 25,000 feet is right here. I mean, this is like the 40,000 feet up here. These things are miles high, these thunderstorms, like miles high. These things are massive compared to like the stratus clouds and everything else. So you want to be aware of that. Those thunderstorm clouds like can be miles high, because remember, miles 5,000, over 5,000 feet. So 5,282, something like that. So those clouds are multiple miles, like 5 miles high, the cumulonimbus thunderstorm clouds. Another thing that we want to be aware of with these thunderstorms, again, they're going to ask a lot of questions about the thunderstorms and the cumulus because they can lead to thunderstorms, and these are dangerous to fly in. So another thing they might actually ask about is that anvil top. So you'll see that on the thunderstorm cloud. So it might say what kind of cloud type is characterized as having an anvil top. That'd be your cumulonimbus, your thunderstorm cloud. Characteristic of mean, nasty weather, thunderstorms with strong wind, rain, and possible hail. They will ask about that one. Okay. What is the minimum visibility required for SUAS operation? Pause the video and tell me your answer. Okay, good. 3 miles. Remember, we have to have 3 miles. Now, that doesn't mean that you can see your drone from 3 miles away. If you're flying a DJI Mini, you're not going to see your drone from 3 miles away. They're tough to see. But you got to be able to see 3 miles away. So if an airplane or a building or a tower is 3 miles away, you should be able to see it. If you can't see it, there's not good enough visibility to fly your drone. You got to be able to see 3 miles away. That's the minimum visibility to fly your drone. And again, I asked you last time, if you like this setup where I go over some stuff and then ask you questions, please put that in the comment section below. That would be helpful. If this is effective, then I want to keep making it like these. If you don't like this, then tell me why. And also give me a thumbs up. The weather report lists the ceiling at 800 feet. What is the highest you can operate your SUAS? So if it's saying the ceiling's 800 feet, it means the bottom part of the clouds are at 800 feet. So the lowest part of the clouds are 800 feet. So remember, how many feet do the clouds have to be above you in order to be able to fly? Correct. 500 feet. The clouds have to be at the lowest 500 feet above you. If they're only 400 feet above you, the clouds are too low to fly. So they're going to be 500 feet above you. So if the ceiling's at 800 feet, what's the minimum height, or what's the highest you can operate your SUAS? Well, that would be 300 feet, right? Because then the clouds are still 500 feet above you. They got to be 500 feet above your UA. So if you go 300 feet up and the cloud ceiling starts at 800 feet, there's 500 feet of separation. I mean, if the cloud ceiling is only 800 feet, you can't go more than 300 feet up now. Whereas normally, if there's no clouds at all, how high can you normally fly? 400 feet. You can normally fly 400 feet, unless there are low clouds, and that's going to keep you a little bit lower. So meaning to fly it, well, actually, I already said that. To fly at all, clouds can't be, if they're below 500 feet, you can't fly at all. What conditions are necessary for the formation of a thunderstorm? Is it high humidity, lifting force, and stable conditions? High humidity, high temperature, and cumulus clouds? Lifting force, moist air, and extensive cloud cover? Go ahead, pause the video if you want. Okay. And the correct answer was high humidity, lifting force, and unstable conditions. Remember, you're going to get unstable conditions because of the hot air from below is rising and the cold air is falling, right? So that's going to give you those unstable conditions. High humidity, as we'll learn in future videos, is also bad for stability. So that's what conditions are necessary for the form of thunderstorm. So that's kind of, just remember this, if nothing else. Write these on a flashcard, because this is very likely to be tested. I definitely saw a test question like this, and I've seen this in the practice tests a lot. Thunderstorms, which generally produce the most intense hazard to aircraft, are. So which thunderstorms are the most hazardous to aircraft? Is it squall line thunderstorms, steady state thunderstorms, or warm front thunderstorms? Go ahead and pause if you want to try to answer this. I don't think I've said this yet. So, all right, the answer is squall. Just know that squall line thunderstorms are the most hazardous to aviation. So most intense thunderstorms for aircraft. A squall line is a non-frontal narrow band of active thunderstorms. The line may be too long to easily detour. It often contains several steady state thunderstorms and presents the single most intense weather hazard to aircraft. Where are squalls most likely to form? Is it high altitude, low altitude, at any altitude? Go ahead and pause the video, choose your answer. And after I say pause, make sure you unpause too. No, I'm kidding. Remember what I said before. Let's say you saw this when you're like, I have no idea. I can't remember. If you're in that situation, I feel like from what I've seen with these test questions, the vast majority of the time the answer is any or all, or that type of answer usually is the answer. Now, I've seen one time on a practice test where it wasn't, but most of the time, if you get that any or all option, go with that. So squalls can occur at high or low altitudes. Let's do icing and fog, and then let's wrap this video up. So icing. So structural icing occurs on an aircraft whenever supercooled condensed droplets of water contact with any part of the aircraft that is also at temperature below freezing. Okay, so if the water touches the freezing metal, then it's going to create structural icing. Icing in precipitation is of most concern to the remote PIC because it can occur outside of clouds, right? So like if there's like rain that then starts to freeze to your propellers, then that could be bad, right? Because then it's going to cause your aircraft to be heavier and sluggish, and it could fall out of the sky. The effects of structural icing on an SUAS are lift decreases, thrust decreases, and drag increases. If it appears that ice is accumulating on the SUAS, it should be recovered immediately to avoid loss of control. You don't want your aircraft falling out of the air, and you don't want to lose your aircraft either. But more importantly, you don't want it to fall out of the air because it can fall on somebody. So if you really shouldn't be flying. I mean, I wouldn't be flying in rain, even if you somehow have 3 statute miles of visibility. But if it's rainy and cold, that's when you can really run into these problems. Because remember, as you get higher up in the atmosphere, it could be colder. So maybe it's not freezing where you're standing, but it could be freezing, a few hundred feet up. It's possible, and that structural icing could possibly occur. So just be aware of those things. Okay, icing and fog. Okay, so dew point is like a cool thing to learn about. Like this is something I feel like until I started learning about this stuff, I didn't know a whole lot about. So this is kind of cool. So the dew point is the temperature to which air must be cooled to become saturated with water vapor. When cooled further, the airborne water vapor will condense to form liquid water dew. When air cools to its dew point through contact with a surface that is colder than the air, water will condense on the surface. Okay, so let's break this down. So basically all dew point means is like if the air cools to whatever the dew point is, to that temperature, then it is going to be fully saturated. The air cannot be more than 100% saturated with water vapor. It can't. If it gets to that point, so let's say we got a dew point, I'm in the southeast and it's summertime, so it's hot. And the dew point where I'm at can be high. I mean, like mid 70s. So let's say the dew point's 75 degrees, and then the air around, that air cools to 75 degrees. Then the dew point is equal with the air. At this point, you're going to get, it's something has to happen with that water vapor, right? The dew point cannot be higher than the outside temperature. So that's where you're going to get moisture, and that's where you're going to get fog. And this is something we got to know. I talked about in METARs. If your dew point is within 3 degrees of your temperature, so say dew point 75 and the temperature is 77, that's when you're going to start experiencing fog because that moisture's got to escape somewhere. All right, so know that if you're within 3 degrees of the dew point and the temperature, that's when you can get fog. They'll ask about that. If the dew point and the temperature are the same, you're you're going to probably have fog, right? All right, so when cooled further, the airborne water vapor will condense and will form liquid water. So that's when you start seeing dew. What happens here is when air cools to its dew point through contact with a surface that is cooler than the air, the water will condense on the surface. So let's say, the dew point is 75 degrees, like super high, like it is here this time of year. And what will happen is maybe you have an object like, it could be your car, windshield, could be the blades of grass or whatever, might be actually cooler than that temperature. So maybe it's cooler than the air for whatever reason. Maybe it was sitting under an awning, so it wasn't getting the sun or whatever it was. So it might be, that surface might be cooler than the air. Well, the air is eventually, it's going to touch that car, that blades of grass or whatever it is. And so that's going to cause dew to form because now when that air touches that surface, it's going to get cooled down to its dew point and it's going to form those water droplets or that dew onto the car windshield or those blades of grass. I hope that makes sense. If that doesn't, say something in the comment section. I'm not going to play this YouTube video for you. I do that for my students, but this is kind of separate, a little separate from the UAS thing, but I think it's really interesting to know. A lot of times we talk about relative humidity when we're saying how humid it is, but really what's better than relative humidity is actually going by the dew point. So let's say, for example, if you have a dew point of 75 degrees, even if the relative humidity is only like 50% or whatever, it's going to feel really, 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 really humid. Oppressively humid is what they say here. So whereas if the dew point's less than 55 degrees, even if it's 100% humidity, it's actually going to feel kind of dry. So it's like the dew point's actually kind of better to go by about how humid it's going to feel than the actually relative humidity percentage that you see. Fog is a surface-based cloud composed of either water droplets or ice crystals. Fog may form by cooling air to its dew point or by adding water to the air near the ground. Fog is classified by the way it's formed. Okay, they're going to ask you fog questions on the Part 107 exam. What I kind of recommend is maybe that you take these, put them on flashcards, write radiation fog on the top and the definition for it on the back. They're going to ask you specific like fog. What is a characteristic of radiation fog? What this happened? What type of fog represents this event? You know, so you know these. Radiation fog formed when terrestrial radiation cools the ground, which in turn cools the air in contact with it. When air is cooled to its dew point, fog will form, like we talked about. Once we start getting within 3 degrees, then you can start seeing fog. This fog will form most readily in warm, moist air over low, flat land areas on clear, calm nights. So that's kind of the question you'll often get. Which type of fog is most likely to occur in warm, moist air over low, flat land areas on clear, calm nights? And the answer would be ground fog or radiation fog. So that right there is very often a question I've definitely seen on practice tests. Advection fog or sea fog formed when warm, moist air moves via wind over cooler ground or water. A warm air mass moving inland from the coast in the winter. So, you know, maybe like in my area, the water might be warmer than the air. Usually it is. And so that could cause that sea fog. You'll see this in other areas as well. But anyway, upslope fog. This is going to be in mountainous areas. So it's formed when moist, stable air is cooled to its dew point as it moves up a long sloping terrain like a mountain. So as you know, the air is moving up the mountain, it gets cooled, and then it gets cooled to its dew point, and it creates fog. And so sometimes when you're driving in the mountains, you'll see like that cloud hanging out at the top of the mountain. That's upslope fog. Precipitation-induced fog. I would say these first three are the ones I see on the practice questions the most. Then I've seen steam fog on there some too. Just saying, write them all down though. Okay. Let's see, precipitation-induced fog is most commonly associated with the frontal activity, and is formed by relatively warm drizzle and rain falling through cooler air. Evaporation from the precipitation saturates the cool air and fog forms. Steam fog forms in winter when cold, dry air passes from land area over comparatively warm ocean water. Low-level turbulence can occur, and icing can become hazardous in steam fog. So this would be like, again, my area, maybe like in the wintertime when the air is cooler and it goes over the water. So we have like the Gulf Stream comes up this way, so the water is a little bit warmer, and that could cause that steam fog. Conditions are conducive to the formation of fog when the temperature and dew point are converging. So again, once that temperature starts to get close to that dew point, you're going to see fog. Within 3 degrees, you can see fog. Certainly, if they're the same temperature, you'll see fog. And they'll ask you that like sometimes on a METAR question. I think I talked about that in my METAR video. Like, which of the following is a hazardous condition that could exist at this airport? And they'll show you the METAR report. And if the temperature and the fog are within 3 degrees Celsius of each other, Celsius, because they use Celsius. And I don't know why the FAA goes back and forth between empirical and Celsius, but they do. For distance, it's feet. For wind, it's knots. For temperature, it's Celsius. But if it's within 3 degrees Celsius, you can see fog. I should throw that Celsius in there because that does make a difference, right? Icing fog or radiation fog. We already talked about that one. I just giving you pictures at this point. That advection fog, that sea fog, that's like San Francisco gets a lot of that. There's some mountains of that upslope fog. Okay, here we go. Question time. One in-flight condition necessary for structural icing to form is, pause the video and choose an answer. Visible moisture. If you have visible moisture and then you're flying up in altitude, it could be colder up there and that could cause that structural icing. So two conditions are necessary for structural icing in flight. The aircraft must be flying through visible water, such as rain or cloud droplets, and the temperature at the point where the moisture strikes the aircraft must be below 0 Celsius. Remember, 0 Celsius is freezing. If you're in America and you go with Fahrenheit, it's 32 Fahrenheit, but the test is, they're going to use Celsius for temperature. So be familiar with Celsius. 0 Celsius is freezing, 100 Celsius is boiling. And honestly, like, yeah, you should know those. It's like good information even outside of this. What environment is most conducive to frost formation? Go ahead, pause the video and pick your answer and then unpause it. Dew point of surface is below freezing. Dew point is above freezing. So, so frost on cool, clear, calm nights, the temperature of the ground and objects on the surface can cause temperatures of the surrounding area to drop below the dew point. Remember, if it drops below the dew point, you're going to get fog. When this occurs, the moisture in the air condenses and deposits itself on the ground, buildings, and other objects in the morning. This moisture is known as dew and is sometimes can be seen on grass and other objects in the morning. If the temperature is below freezing, the moisture is deposited in the form of frost. What situation is most conducive to the formation of radiation fog? This is like really how you'll see it on the test. Pause and then answer and unpause. Warm, moist air over low, flat areas and cool, calm nights. If you got that wrong, please make your flashcards. Just make your flashcard radiation fog, and on the back, put this on the back. A lot of this, some of this stuff on the test is just memorization. So just take the time to memorize it. All right, I think I pretty much said this. I'm not going to read that again. In which situation is advection fog most likely to form? Pause and then choose your answer and then unpause. An air mass moving inland from the coast in winter. Remember I said San Francisco, right? So they're like on the coast and the air is coming from the west and it comes right over that city. So that's why they get a lot of fog. Advection fog forms when moist air moves over cooler ground or water. It is most common alongside coastal areas. This fog frequently forms offshore as a result of cold water, then it's carried inland by the wind. And in like California, they got real cold water over there. That's why they see it so much. All right, we're going to stop for here. We'll go over density altitude in the next video. Hey, thank you for watching Mr. Mig's Classroom. Please go ahead and give me a thumbs up. I really appreciate that. And put some comments in the comments section. If you like the video, say so. If you have questions, say so. If you like this format where I do these question and answer type of thing, I keep this, say so. If you don't like it, say so. So, and make sure to subscribe and give me a thumbs up. I'll see you next time. We'll talk about density altitude. Until then, peace.